Hey, welcome everyone. Let's see, so I'm always super happy to come back to Portland. I went to college here, so I'm a Reedy, but then ultimately ended up in California at Stanford and have been now in Palo Alto for many years. I spent some time working with a social networking company in 2016, and that got me interested in privacy. And so I got really interested in this notion of restructuring parts of the internet so that compute and personalization and things like that can take place at the edge on people's phones. So one of the things I'm generally interested in is this notion of how do we architect the internet in ways that better reconcile privacy and personalized services that are being provided by companies such as Meta and Google and so forth. So in this overall trajectory of getting interested in privacy and the internet, one of the areas that's of course super appealing to all of us are distributed systems and decentralized systems. And so back in 2018, I founded a company that then ultimately morphed into Boba Network. And the point of Boba Network is to be a layer 2 scaling solution. And what's really interesting about layer 2 scaling solutions from my perspective is not cost and speed at all. And so typically when you think about layer 2 scaling, it's all about making things really cheap. But there's something really unusual about layer 2 scaling solutions, and that's the absence of mining. If you think about the original architecture of Ethereum, of the Ethereum EVM, a lot of simplifications were applied to the EVM to make it compatible with mining. So there's a real difficulty if you think about doing complicated math in a decentralized system, because if each one of you is running their own random number generator and you're also mining, of course, you would have an incredibly difficult time in figuring out what the quote-unquote correct state of the blockchain is, because you would all have a different perspective on what is right and wrong. And that's one of the reasons that it's difficult to get random numbers out of the EVM. So that simply reflects the requirements of a decentralized compute system. But of course, in the L2 space, whether it's Optimism or Boba or Arbitrum or whoever else, they're generally all running unitary sequencers. So there's no mining. And that opens up a major technical opportunity, which has to do with writing or significantly altering Geth to do all the math you've ever wanted it to do, and also to interact with any other computer on Earth in the context of a Solidity smart contract. And that's important for two reasons. The first reason it's important is because it makes it trivially simple to mint NFTs with random attributes inside a single transaction without waiting for any kind of VRF situation with multiple contract calls or something. So NFTs get super simple. The other thing you can do is you can do arbitrary math, floats, stochastic gradient descent, AI, whatever you want. And the other thing that happens is that you can interact with any other computer on Earth. So from inside your Solidity smart contract, inside the EVM execution stack, you can call any API you want. We just completed work on a system for querying the Spotify API using our native token. And basically inside the smart contract calls an external API, computes on the results, and returns results to the person who triggered the transaction. So that's never before been possible. So these are atomic transactions that interact with other computers that generate random numbers and can accommodate floats. I'm sure you've been annoyed that the square root of 3, according to the EVM, is 2, which of course again reflects the strong constraints of a decentralized compute system. So Bitcoin, Ethereum, obvious. In the one case, we're dealing with a Turing-complete programming language. In the other case, we have a minimal stack-based programming, which of course is powerful enough to do lots of things. But of course, as a mathematician or physicist or an artist or someone else, you of course want to be able to draw on a much richer architecture. So if you've ever tried to do fancy math on Ethereum, that's been super annoying because in many ways, it really hasn't changed since 2015. You're still dealing with something which is like a 1950s pocket calculator. You can do really simple things, but for a lot of stuff you'd like to do, you can't really. Fundamental issue, as discussed, is that to build a decentralized computer, traditionally you've had to put strong constraints on the set of math operations you can do. In the setting of a layer 2 scaling solution, that's not true anymore. So what we've done at Boba Network is we've modified Geth, which is the block forming code in Ethereum, with atomic support for things like RAND and client call. And I'll try to illustrate why that actually matters and why you should care in a moment. If you've ever tried to mint an NFT, you know that it's painful to get random numbers. If you do so on Boba, then you simply do Turing.getRandom and you get a random number. Just like in Python, just like in any other computer language that you're used to. If you'd like to interact with the Spotify API or the Facebook API or geolocation or Bloomberg or Dow Jones or Polygon.io or your favorite provider of whatever information you need, you just do Turing.getCurrentQuote in the case of querying a price feed, for example. So what the technology is allowing you to do is write smart contracts in Solidity and deploy them on Boba Network, a Ethereum-focused scaling solution, and do all the things that you're used to doing with normal code inside one transaction. So this is super fast, it's convenient, users like it because things just happen in one transaction, they don't have to sit around and wait, and it also makes your life as programmers and hackers much simpler. Who here cares about the nitty-gritty details of how Geth works and how we managed to hack Geth to do all of this? 1, 2, 3, 4. So those are all the people in this room that actually matter, saying super annoying things. But if you dream in Geth and love Geth, then so I'm going to drag you through this. The way this actually works is that Geth, of course, is all-knowing and all-seeing. So Geth certainly has a good sense of what opcodes you've just invoked. We can intercept some of those. We can then do stuff like generate random numbers, call external APIs. We can then replace the call data you provided with enriched call data, such as numbers from a random number generator, and then we can execute those opcodes with the enriched call data. So from the perspective of writing blocks and so forth, nothing has changed. It's just that we intercepted your incoming transaction, we added stuff, and then we sent the augmented transaction back into the call stack. There's a few really interesting sort of architectural features here, which is we take all the information that's returned from off-chain and we write it into Ethereum. That means that there's an immutable paper trail of what happened. So even if you don't trust us, you can go to Ethereum, you can look up every single incoming call and every single augmented or changed call. You can compare those and you can figure out exactly what we're doing. So this basically allows Ethereum to also replay those transactions because all the data is written into Ethereum. So anyone can look at the system from the outside, compare inputs, modified inputs, and the state of the chain that we report, and give us a thumbs up or thumbs down about whether we're doing the right thing. So there's obviously a lot of things that need to be fiddled with to get this kind of system to work. So your RPC call comes in, we figure out if this is a special Turing call, we interact with an outside computer API. By the way, we're just writing a plugin for Unity. So if you're a gaming person, you use Unity, wouldn't it be nice for you to have a plugin that talks directly to a blockchain? And if you've just slayed a dragon or climbed a mountain or found some gold, that can be instantaneously connected to actions on a blockchain. So there's your external API, Unity, Spotify, whatever. Then in the L2 geth, we replace the original call data. We form a new block. We've had to change the Ethereum block headers to add extra information, right? Because there's extra information being injected into the system from the outside. So we need to keep track of that so you can verify all of our transactions. All this information is then written into Ethereum, which is here just denoted as this dashed line. And then it's pushed through all the other parts of the system so that ultimately it's possible to verify these transactions and then replicate them for all the callers. So they have like good RPC nodes to work with. Since it's Friday afternoon and I'm the last speaker before you can actually do fun stuff, I'll breeze through this. All these slides will be online. Don't worry. This is not my class, so you're not going to get graded, and you don't have to worry about any of that. This is just for fun. Some of the example uses we've coded up on our mainnet is a very simple Twitter activity-based Boba fountain. So if you talk to 10 friends of yours on Twitter, you get some Boba. We've coded up some CAPTCHAs for smart contracts. So imagine requiring someone to play a little game before something happens on a blockchain. We've used the random number generator to do monster mint about 2 weeks ago. We had 1,000 Turing monsters minted in 12 seconds. Using the internal random number generator inside our geth. So that's obviously super fast. Imagine a classical system. Imagine minting 1,000 NFTs on Ethereum. You would definitely clog things up for quite a few blocks. People would be annoyed. They'd be screaming, super expensive. But we're able to do it in 12 seconds. And then we're increasingly using Turing or the system to query commercial data sources for trading data. So that's what a lot of the DEXs are doing and the more DeFi-related projects. So the point of the technology is to connect your smart contract with any other network computer and quickly build super interesting new stuff. So the link is bit.ly get Turing with an uppercase T, which is my fault. I should have made it lowercase. There's some major caveats if you care about security. So first of all, of course, you shouldn't trust anything I say. You should really only trust what's in the blockchain. And you should also trust cryptography, of course, well, certain flavors of it. And so just keep in mind there's important sort of security ramifications. For example, if I say that, oh, I've created this wonderfully random number, you really shouldn't trust that. You should, there's much more to that. There's no system in place for verifying off-chain inputs. Basically, if you call an API and that API is lying to you, there's nothing you can do. This is the standard Oracle problem. This is one of the biggest unsolved problems in all of decentralized systems, which is connecting real-world anything to on-chain events. There's only one known solution to the problem, which are DEXs, distributed exchanges, because there people trade, and so you're able to establish prices on-chain. But everything else is a largely unsolved problem as it relates to oracles. And of course, there's no direct connection of any of this technology to the thing that I actually care about, which are things like privacy-preserving compute. But it turns out that some of this stuff is actually useful for things like secure multi-party computation and homomorphic encryption, which then starts to get a little bit more interesting. Imagine doing homomorphic encryption on Ethereum. So forget that. But it's the sort of thing that can be done off-chain and then integrated with things that are happening on-chain. So the TLDR is, this slide here is totally wrong because it's a few weeks old. So this is actually went mainnet after ETH Denver. Detailed write-up should be easy to get. I'll be here for the entire night. And we've designed it to be super easy to use. Need a random number, Turing.getRandom, inside your smart contract, and you're all done. So where we see Ethereum going is really not only will Ethereum get like faster and cheaper because of architectural improvements, but we really want to get Ethereum to the point where it's also a much more powerful computer. And part of the power of a computer has to do with the number of other computers it can easily talk to. And that's why we're getting a lot of traction from Web 2 companies. So these are big, quote unquote, old companies that say, oh, I have all these APIs, I have all this infrastructure deployed. What's the easiest way for me to build out a crypto payment rail? What's the easiest way for me to connect my air miles to a blockchain and vice versa? And so that's part of why we're building what we're building. Our job is not only to make things cheap and fast and, of course, be trust-rooted in Ethereum, but connect Ethereum to every other computer on Earth and to do it in really simple ways. So please build amazing things, and I'll be here the whole time to help where I can. I don't trust people who code, so who don't code. So by definition, since everyone here in this room also codes, you're already part of the trusted circle, and so I look forward to helping as much as I can. Thank you. And here's some of the stuff I'll be working on tonight. Go ahead.
I can certainly appreciate the random piece of Turing. The off-chain calls. I mean, you've got a big slide of caveats there, right? And so then what? Having not solved the Oracle problem, why would I use this? Or and are we propagating potentially untrusted data to the L1?
Totally. So there's some people in this room, and for certain use cases, you should never touch this with a long stick, no question. But there are other situations where it starts to make sense. A great example would be a game, where the financial sort of ramification of getting the internal game state wrong, not so big. Game players are notorious for wanting great games to play. They don't want to be dealing with like MetaMask pop-ups the whole time and other stuff. And so there are many use cases where people are quite comfortable. For example, if you play a game on Unity, then Unity is ground truth. That's the game. And so if you connect your game engine to a contract, there's really no obvious way to even validate that. That's just the nature of the beast. And in terms of financial data, there things get a little bit more tricky, because we could do a lot of things. I could manipulate, other people could do funny stuff. And so the recommendation there would be that if you're using Turing for price feeds, to obviously only do that in a context where you have multiple price feeds being aggregated. So where we're seeing companies use Turing is as a final thumbs up, thumbs down on estimates they've obtained elsewhere. So they'll typically go to 2 dexes and some Oracle. They'll determine a median, and then they'll determine some error bars on the median, and then they'll do a final check with a well-known high-profile price feed system like Bloomberg, and they'll simply say, is this within 8% of Bloomberg? Yes, no. If not, then put up a unreliable flag. So that's a justifiable use case as like extra data input, but then relying exclusively on Turing or relying exclusively on any one data source, frankly, you're just asking for trouble. Only the paranoid survive. But have fun, build some amazing stuff. You can now connect a Solidity smart contract that's running on an Ethereum-focused L2 with any other API you want. Thank you.